everyone. So this video is going to show you how to properly set the spatial reference for assignment 5.2 solar roof housing study. So in class we sort of went over this, but I wanted to talk about it here as well. So in your textbook, there is on page 170, there is some information on how to look up the zone in the state plane coordinate system. And one of the big issues is that the way that it has set up with the instructions here, I assume is outdated. So there was a little bit of a hiccup there on where to find the information to do this. So if I go to NOAA, the NOAA website given in the textbook, NOAA.gov, NOAA, what is it? NOAA.gov, right? Just NOAA.gov. Oh, NGS, NOAA.gov, NGS, NOAA.gov. What will come up is the geodetic survey, and when I get here, I'm actually looking for the toolkit. So under tools, I'm actually looking right here for the coordinate conversion and transformation tool. Unfortunately, the tool that they had spoken about in the textbook is no longer useful. Okay, so here's what we're going to do. So we're right here now on this website, and I already am here. So what happened is I zoomed out to the United States to be able to find Arizona, and I scrolled over and then I zoomed in to Phoenix, Arizona here. And what I did was this. I know this is that NAD 83 is usually what the input datum of many sources are, and then the output datum, I'm actually going to use this HARN, and I know this because of just from a website research that I did for this project. And what I do is I clicked convert here. So this is what your input datum is, this is what your output datum is. So this is trying to tell you, like, okay, so if my input data says this and my output data, I want it to be this, how do I change the projection systems to be able to do that? And this tool down here will tell you the zone that you can choose under projections in the project area. It's very confusing, but once you start doing it a couple times, it becomes second nature. So what happens is here, so I scroll down and look here, it says the UTM is zone 14, and this is what's really important. So the UTM is zone 14. I need this number because when I go back, because now I know what zone it is for Maricopa County, Arizona. So now when I go here to my project, and I'm at my project here, and I want to set my coordinate system for my project, I can, so the first thing is that you can set the coordinate system for your project in general. And in order to do that, you hit options, and then you go here, and in options you go to maps and scene, and if you look here it says spatial references. So this sets the default options for new maps and scenes that come in, and we are going to choose a spatial reference. So we're going to click here, and remember that UTM, the UTM zone 14 that we had picked up on the other website. Now there's both geographic coordinate systems and projected coordinate systems. Geographic coordinate systems are, it's the way that we know where certain points are on a map. And these are updated throughout time, but it's the way that we know kind of where one specific point is versus another specific point. And these change over time depending upon how we look at maps. And so that is why coordinate systems are really, really important. So it's like they give you the longitude and the latitude in the year that longitude and latitude was created. So that's why you'll see different ones like 83 and 2011, because sometimes they update these in order to show the new coordinate systems that they're using. Now the projected coordinate system is how the map is viewed, and that's really important, that there's different ways that we project onto maps, and in class we'll talk about all the different projection systems that there are. So because the instructions say that we're going to find and set the spatial reference. That is the projection. This is really confusing the way that Esri has this set up. So because we're looking at the projection, the spatial reference, we're going to look under here. And if you see here, there's UTM. The UTM coordinates correct with that Arizona. So you can click, here we go. There's different UTM zones that are available, but we want to click here on North America, and we want to scroll down, and we want to pick NAD 83 Harn, okay, UTM zone 14. So NAD 83 UTM zone 14N, and then we click OK. And that has now set the projection for this project. Now here's what happened. I did the project, and then I went back to do the coordinate systems. You can see it's a little crooked now because I set the coordinate systems. So there are ways that if you brought in your data and all of your data has different projection and coordinate systems, there's ways that you can transform all of that into one. It is a little bit of a process, so that's why it's really important for you to set your projections before the project starts. Okay, so in the future, it's good to always set your projections before it starts. If you've brought in your data and you need those transformations, then you're going to want to see me in class, and I can help you with how to transform your data into one. If not, it's not the crux of this assignment. The bigger idea is that I want you to be able to create a new feature class. I want you to be able to join the tables. I want you to be able to bring in the data and download it. So if you can't get the coordinate system projection excuse me, updated, it's not going to hurt your grade. Okay, so please, we'll work on that more in class, but right now in this introductory class, it's not going to give it is really important, but it's not going to sway your grade either way. Okay, so if you have any other questions, feel free to reach out, and I will see you in class.